sketch of the curve with the equation y equals the square root of 3 minus x times x plus 1 between 0 and 3. The finite region R, shown shaded in figure 2, is bounded by the curve, the x-axis and the y-axis. We need to use the substitution x equals 1 plus 2 sine theta to show that the integral from 0 to 3 of that function with respect to x in the theta world can be written as k times the integral from minus pi over 6 up to pi over 2 of cos squared theta d theta. And we need to figure out what k is. So first thing we always do when we do integration by substitution is we're going to differentiate our substitution. So let me just write down the substitution at the top here. X equals 1 plus 2 sine theta. So I'm going to differentiate this. The 1 will disappear. The 2 sine theta will differentiate to be 2 cos theta. And then I'm going to multiply both sides by d theta. So move this up here. And so that is my dx. So that is what I'm going to substitute in instead of the dx there. Next thing I want to think about is my limits. Because I need to show that when x is 0, what's theta going to become? So, when x equals 0, I'd get 0 equals 1 plus 2 sine theta. So, minus 1 equals 2 sine theta. Divide both sides by 2. So sine theta equals minus a half. If I do inverse sine now, so sine inverse of minus a half, and that's minus pi over 6. So when x is 0, theta is minus pi over 6. What about when x was 3? Let's do that now. So when x is 3, I get 3 equals 1 plus 2 sine theta. Subtract the 1 from both sides. Divide both sides by 2. Do sine inverse. Sine inverse of 1 is pi over 2. So when x equals 3, theta is pi over 2. So this explains why my 3 has become pi over 2 here, and why my 0 has become minus pi over 6. Right, make sure you've got those corrections down so far. Press pause if you need to, because I'm going to move on to the main course of this integration by substitution. Right, so we are going to replace the inside. So we've got the square root. Right, okay. So the square root of 3 minus x. Now x is 1 plus 2 sine theta. So all I've done there is swapped the x with the 1 plus 2 sine theta. And that's multiplied by the second bracket, which is x plus 1. Remember, x is 1 plus 2 sine theta. Plus the 1. And that gets multiplied by my dx, which is the 2 cos theta d theta. Right, clearly you can see we've got quite a lot of work to do simplifying this square root here. So, let's deal with these brackets first of all. So in the first bracket I've got 3 minus 1, which is 2. And then I've got the minus 2 sine theta. The second bracket I've got 1 plus 1, which is 2, plus 2 sine theta. I'm now going to expand those brackets on the inside. So the 2 times the 2 is 4. The minus 2 sine theta times plus 2 sine theta is minus 4 sine squared theta. And the other two terms, when I expand those brackets, are going to cancel out. Right, 4 minus 4 sine squared. Hopefully you should recognise that we could think of that as being 4 lots of 1 minus sine squared, which is going to be a good thing to do because the 1 minus sine squared is the same thing as cos squared. And the square root of 4 cos squared is 2 cos theta. Timesing those two things together, we get 4 cos squared d theta. I can take the 4 outside because it's just a constant, so that is the value of k that I needed to show here. And obviously at the beginning of this video I showed why those limits have swapped. So there we go, that is part A of this question. I think this is the key step from here to here. Right, make sure you have got all of those corrections made, because I'm going to clear my screen and we're going to move to part B of the question. Press pause if you need to. Right, part B. Hence finds by integration the exact area of R. So we know that k is 4 now, so what is this integral? In order for me to integrate cos squared, I need to use the cos double angle formula, which I know cos 2a is 2 cos squared a minus 1. So let's rearrange that to make cos squared the subject. Divide by 2. So I know that cos squared is a half cos 2a plus a half. Or in this case, because I had a 4 cos squared a, times both sides by 4, then I could say 2 cos a plus 2. So this is the same thing as me integrating 2 cos 2a, or 2 theta it should be in this case, plus 2 d theta between pi over 2 and minus pi over 6. Whenever we're integrating cos squared, this is always the process that we do. Because both of these terms are nice and easy to integrate now, cos integrates to be sine. So I'd have 2 sine 2 theta, but then by the reverse chain rule, I'd have to divide by 2. So dividing by 2 means that actually that 2 at the front cancels out. Plus 2 Integrate that, we get 2 theta. Now just to substitute our limits in. So sine of 2 times pi over 2. 2 times pi over 2 is pi. Plus 2 times pi over 2 is pi. Then we have sine of 2 times minus pi over 6. So that's sine of minus pi over 3. Minus, also, well no, actually will be a minus. Plus 2 times minus pi over 6 will be minus pi over 3. Sine pi is 0, so we don't need to worry about that. Then we have the pi minus pi over 3. So that's going to be pi plus pi over 3, which will be 4 pi over 3. Then we just have the sine of minus pi over 3. So sine of minus pi over 3 is minus root 3 over 2. So all of this is minus root 3 over 2. Which, when you take into consideration of the minus at the front there, those two minuses are actually going to become a plus. So my final answer to this question is 4 pi over 3 plus root 3 over 2. And I'm going to leave my answer like that. That is the exact area of R, so we can leave it in that form. Make sure that you have made all of your corrections. Go back and re-watch this video if you need to, because this was a tricky question.